I'm going to save this one in the unit 6. I'm going to save this file, and we'll call this a list.py. And okay, so list. So list is a type of, we call this data structure. Okay, there are a couple types of data structures in Python. When we say data structure, we're not talking about integers and float, things like that. Data structure is where data are contained within some type of containers, like list. We'll learn more about like tuples and sets, maps, and dictionaries. Okay, all those are different types of data structures. There are many more as well. You have the linked lists, objects, all the different types. But data structure, in this case, is where you have, it's basically how data are organized in a group or a container. Okay, that's what list is, one of those containers. A list is, in a way, it's kind of similar to a string. We learned about string before. It's similar in the same way how you access the elements, right? You access each character in a string using the index numbers, right, in the string. The list you access exactly the same way, using the index. Now, a list is also known as arrays in some languages, like Python, Java and C# and things like that. But a list in Python is different because it is arrays plus the array list in Java, or basically just called list in Java. Okay, I'll put here so you can kind of, if you look at that, you see that arrays and array lists are different in Java. They're two different data structures. The reason why list is really a combination of both of those. What I mean is that in arrays, in standard arrays in Java, okay, once you declare an array of certain size, then the size that you set is fixed. You cannot change the size. You cannot increase it. You cannot decrease it. If you set an array to contain, let's just say 10 items, 10 elements, that's it. You only get 10. Okay, whether you use all 10 or not, it's 10. Okay, that's arrays. If you want that size of the array to be, sizable, like you can increase the size or decrease it, then you have to use what's called the array list in Java. Okay, so that way you can grow, the array can grow and shrink, and it's more dynamic that way. It's really, really useful because you want to do that in certain situations. But the way that you access arrays in Java, if you're using arrays or array lists, is very different. Arrays you access using the index, just like you do here in list. But if you use array list, that array like shrinks and grow, you can't use the square brackets. You have to use a function to get that. Okay. But list in Python is a combination of both of these, and you access it using the index. Okay. There's no like get the item of the, so there's no get function to get a certain list. Just put a bracket, you're done. Very simple like that. So one thing that is similar, I mentioned that list and string. So for example, if you have a string called message in string, we have like Python, right? So the word Python, there is a string, and a string, in this case, we say string are this term here, you hear probably, if not now, you hear now and you hear in the future also, are called immutable. Okay, or types. Okay, just say just type immutable. The word immutable means the data cannot be changed. Whereas list, here lists are mutable type. Means data can be changed. So you may wonder, what does that mean? Data can be changed or cannot be changed. So, for example, the string here, the word Python, I create a variable called message that has the word Python. That means I cannot go into the string here and change or add something to it and make the word pythons. You can't. Okay, there's no way to do that because the data cannot be changed. I can try to append to it, or not even append, I can concatenate with it. But even so, if I do something like message is equal to, it would be like a new message equals to message plus the exclamation mark, for example, right? What I get is the word what? Python with the exclamation mark. It's a new variable. And if I do message is equal to message itself plus that, okay, like that, I get the word Python with the exclamation mark. What happens behind the scene is that every time we do an assignment for a variable, if it's a string, this string here, even though we have the same name, this is just a placeholder. Okay, every time we do this string here gets recreated all over again. It's not, okay, I already have the word Python. I just attached the exclamation mark to it. There is a new word. It's not it. The whole thing gets wiped out from memory, and it recreates the whole string again, fresh. Okay, so you cannot change it. That means you can access it, right? You can access like message of 0. That will have, if you echo that out, right? If I echo that out, echo, that's PHP. Sorry. If I print that out, if I print message of 0, then yeah, I'm going to get the letter P that you see here, right? Because that's how you can access each element. But you cannot change it. That means I cannot say, okay, I want the message of 0 to be something else, like maybe K or something, right? Okay, if I do that, and I'm going to print it out. I know there's no meaning, but if I do that. Okay, so see that it's not legal. You cannot change its data. It says object does not support assignment because it's immutable. That's what it means. I can access it, but it looks like, oh my god, I can just change it to a K instead of P. Right? You can't do it. To do that, how would you do that? Well, you have to remove the P and then recreate the whole string again. I cannot replace each of these strings. But there are some string functions built into Python and many languages as well that you can replace. There's this replace function. You can swap out all the letters and replace with a new one. It happens behind the scene. The real thing you don't see is, again, actually it would just basically take the whole word here. It will loop through every single character, matches all the characters you find, deletes those, and recreate a new string again, assigns that, and sends it back to you. Okay? So when you do that, you're not going to change the original string. It won't change. It won't happen. You just have a new string be assigned to itself. Okay? So that's immutable. And which makes perfect sense because that means immutable means the message here stores the actual data called Python or Python exclamation mark. And if I were to say something like, we know this is illegal, so I'm going to remove that. If I were to say, I print that message, the whole message out, so it should say Python with exclamation mark. And if I create another variable, let's call it message, let's call it word. Word is equal to message. So if I print word out, what should I get? Do I get the same message? What do I don't? Should be the same, right? Yeah, so I get Python. It's perfect. Okay. And again, it's because it's not mutable. That means each variable stores the actual value, right? So when I change the word to say, okay, word is not message, but it's now I don't know, Java. I mean, it's not. Yeah, it's Java now. So if I print a word again, it should say Java. If I print a message, what should message be? It's not a trick question. We study Python. Yeah, right? So the first one, Python. I changed the word to say Java now, and then I print it out. The word says Java, but the message is still Python. So that means even though I assign word to point as if it's pointing to message, now they have the same word. If I change the word, it does not affect message. Okay, it's original variable. Again, because it's immutable. You cannot change data. List, however, is completely not true. Okay, list will be different. Now let's just say I'm going to do list. I'm going to comment these out. And down here, we'll do a list. So if I have a list called, I don't know, numbers. Don't like numbers. Just say words. Okay, because lists, usually we think of lists, if you think of arrays, it's a collection of data, right? And Python, we don't care what those data is. It can be any data type. It doesn't matter. So usually when we use lists, the variable names are preferably to use plural because it contains more than one item. So I have words is equal to list. So when you declare a variable to use list, and you see that it uses these square brackets by themselves, right? You don't put in front of another word like a like that. If you do that, that's different. I'm accessing the element of a particular variable here. But to set or to create a list, just set the name of the variable equal to a collection of data. If you leave like that, that is the empty list. There's nothing there, right? There's nothing. And if you want to have just one item, like Python again, then that contains one item. We call these items the elements. Each element. Inside the element, I mean that slot there, it's the index 0. So it always starts at index 0, regardless of where you start. It always starts 0 because it's zero-based language, and from 0 to n. So however many you have on the list, that is the n element. So if I put Python here, okay, and if I print now words, I just print a whole word, not just one, but it's going to print the whole list. If I have one, so it'll just be one. And if I go ahead and clear my screen over here, now if I run it, you see the word Python in there. It's in the brackets, just to show you that it's a list. Okay. To print the actual word out of that without the brackets, then you will reference its index. So that would be the index of 0, because there's only one word in there, right? And again, it always starts at 0. And now when I run it, we'll just have the word Python without the brackets, because I'm actually accessing the actual element and not the entire list. If you see something like this with the brackets, this means it's an object. It's not the actual value. But Python is nice. It's very nice because it shows you what's inside the list. Java doesn't do that for you. Java will give you an address to what the list is. So here's what I mean by mutable. Means I can change the content in here. So notice this is one element, the whole word there. But the word is a string, right? So I still cannot change the word Python in there to something else just by changing its character, because that is a string. What I mean is that I can have like a list of items here, right? Java and C#, example. So now I have 3 words. Print them out. I print the first one only. Yeah, it's called Python. If I want to change the first word to something else, then I can just change it like I did before with the string, because it's mutable. Okay, so I can change the element value or data, but the element itself, it has its own data type, right? So you cannot change Python, but I can replace Python with a different word. Say words at 0. I want that to say, instead of Python, maybe I'll say JavaScript. So now if I print the words at 0, or if you print the whole list, we'll print the whole list up here as well. You can see. You see that I change Python to JavaScript. Okay, so I'm basically kind of like replacing the content, whatever it was, to something else. And because it's a list, you can do this type of assignment. And it will look very similar to the string that we did up here. It wasn't legal. Okay, so it's immutable. It also means if I do like I did earlier, let's just say I have another another word here. I have let's say data equals words, just like I have word equal message above. So data has the same content as words. If I print it out, print here. I put here data, so you can see. And I put data here. And we'll put words up here too. So words. So we can compare the two here. And I'm just going to remove this part. Okay, we already showed that we can change its value. So I'm expecting to get the same information, which is true, right? The same copy. So words, couple data is now equal to words. I print them out. Great. And let's say maybe down here somewhere along the way, I say, oh no, I want to change data, the word from Python. I want to change that to something else, back to JavaScript. And then I'm going to print both out again down here. Save that. And I run. Well, what happened? Right? I did not change words. I only changed data's the 0 element to JavaScript. But when I print it out, words is also changed. Right? I didn't do anything to words. Okay? So this is mutable data. Not only that, a list is different from string because strings are immutable, and string is it's just a different type. But a list is also mutable, and I should add another word up here, is also a reference type. Okay, string is non-reference, meaning that when you have the actual data for strings, it has the actual value stored with it. But for a list, it has a pointer that points to the actual value. Okay? So that's why when I change something that they share, when I do this, if it's a list, if I do this assignment, that means the words variable and data variable, they point to the same memory address.
That goes to both directions.
Yeah, it goes to the same address. So whichever variable you use, it doesn't matter in this case. If I modify the data, it affects all the other data as well. This is similar to if you have your bank account, right? You give your credit cards to your family members, anybody who has the card. They access the same account that you do. If you add money to it, yeah, you have money. It's in there. If somebody took it out, well, it's gone. There it is. Okay. So a reference type is always like this, not just true in Java, or Python, pretty much any language that you come in contact with. So be really careful when you do this. This is not copying what words have to data, and so I can use that along the way. If you're not careful, if you work in the real world, and you happen to do this, you accidentally delete some data through data, if you can't recover it, be careful. Especially if you have sensitive data. Because this is not a copy. This is, you have just create another object that points to the same data. Okay. What if you want to copy those data? What do you do? Right? How do you copy each of those exactly same data here to data so that I have a copy and not the actual original source? So I can play with those data. And that's why we learned loops last time, right? You loop through the whole string of words and then add that to the data. That's one way. Another way is the shortcut. There's always a shortcut. I think if you do something like this, okay, this is words. I just want the content of this word. So what you do is you just wrap it like that, I think, if I'm not mistaken. And we'll see what it looks like. Okay, so I'm converting words into another list. But this list is now, it belongs to data, right? Because I'm extracting all the data from the words to another list, assign that to data. So that when you print it out, you see that it's independent. You get the same content. So again, it's a shortcut to copy. So later on, what if I have an assignment, I say, okay, I want you to copy this to the next one. And I say, don't use the word list. You cannot use the list function. And then just make sure you use loop and then loop through every word and then just copy over, right? But of course, that's the shortcut. And this list function is really, really useful, very powerful in Python to do something like that. Imagine if you have like the word above here, like this one here, message. The message is called Python, and I'm gonna copy that and put it down here again so we can see. Okay. So I have the same word. It's not the same data. It's replacing that new one. And if you want to convert that to list, so what it would do is that if you call a new message, I call it MSG. If I put list, if I pass the string message to list function, what you will see inside the message is really interesting, also really useful. Okay, and I'm going to run it now. You see that it breaks that string into each individual character and assign that into each element in that list. Right? Pretty cool, huh?
No.
Yeah, pretty cool. So now you can have a whole paragraph of data and you can put that into a list because again, list and a string are very similar in the same way so that you can access each element using the string, or if you convert to a list first, you can do that. Well, what is the advantage of that? Because I can get the message out of this. If I want to get the first character or the second character, I just put the message of 1. Same as saying if I print message of 1, right? So what's the advantage? Well, the advantage is because a list is now a list. It has a lot of built-in functions to it. What can you do with that? You can sort them. Right? You cannot do that with string. You can't. Because again, it's immutable. I cannot replace data around. You can't do that. But now you're dealing with elements. I can swap the two. If I can say, okay, from small to largest, or replace y with something if it's in the list, replace y with PIE, or something like that for Python, right? You can do that with the list. You cannot do that with string. So, okay, so I test myself. Okay, using this string here in the list, I want you to sort this string and using list and string and print back as a string, right? So you can say, okay, how would you do it, right? So you can say, okay, it's a string. I'm going to convert it to a list. I'll sort it and then change it back to a string, right? Pretty cool, huh? So your question, okay, so can I just do maybe str string a to str message then? Let's just say I sort message. To sort means just put message dot sort. That's it. Because the function will sort your string from smallest to largest using the ASCII character, ASCII number. So it's going to go, H and then NOPTY, right? And what happens when I print string A? I'll put here string A so you can see. We'll print the sorted string to sorted message. You can see that's sorted. So what happened? Didn't do it, right? Yeah. So there's no, you can't convert it to a string just because you can. So then you have to go and create every element and then loop that and append that to strings. Because again, string is immutable, so you cannot magically append data that way. Okay. But indeed, list is really, really interesting. It's really powerful. It has sorting function. You can sort characters. You can sort. Oh yeah, the way it's sorted here, you see that. Why P comes before H?
Capital letters.
Yeah, why?
As I learned from my decimal assignment, capital letters have a different value and come first.
Mm-hmm. On ASCII table, right?
Yep.
Because those comes first, so the smaller value comes first. But so be careful there, right? You can sort them. You can, because again it's immutable, is a reference, and you can also append data to the list. The list can grow or shrink. Okay, you cannot do that with strings. You either have a fixed string size, or you can recreate a new string and have a different size. You cannot do that using strings. So that means if I were to comment that out, and so I have, let's unsort this. I'm going to go and change the sorting. Let's just move that to the bottom here. So we got the message here for Python, and I want to print the whole message out. So again, just want to see that the word Python should be there. Oh, let's turn all the other one off too. There's a lot of stuff here. All these guys off. Okay. So we have the word Python there, one string at a time, and we have about 6 elements in there. So the size is 6. If you want to know the size, and I'll just do here on the console. Okay, it's much faster that way. Since we know that the MSG is already here, it tells you already 6 is the size. So you can find the size of that string by just typing, just like before, the length function. You pass into itself the message object. It gives you a string element of 6, the 6 elements in the list, and the index is always be 0. So P will be the 0 position, and then the last index will always be 1 less than the maximum of the size of the string, of the list. Same rule as a string. Okay. If you want to add more data to it, then you don't have to do like string. String is if I have Python, I showed you earlier, it would be the Python plus whatever it is. Here, if I want to add something to it, I just do message append. I call the append function. What am I appending here? I append a new character or a new word, doesn't matter. I append it to message, and our message now has the exclamation mark in there. You can see here now it's live, and the size has been changed to 7. So it tells you right away, right here. And so if I were to do the length, it's going to give me the size of 7, right? So it can shrink and grow. If you want to remove that last one character here, for example, you can do a message.pop, called a pop function. The pop will always pop the last element on the list. Okay, so if I hit that enter, you see the exclamation mark is now removed. My list shrinks back to 6. Okay, you cannot do that in string. You have to rewrite the whole string again. If I want to remove a certain position, like the H, for example, that'd be a 0, 1, 2, 3 position. So you just say message.pop at the 3rd position, and it removes that out of the list. So your list shrinks and grows dynamically this way. It's really, really powerful, really useful. And if you want to insert it back, well, you can do insertion again, right? And you can say message.insert. It will take the position and what a value that is. So I think, let's see what the first one is. Maybe I'm inserting, I don't remember which one comes first. The index first? Yeah, so it'll be 3, right? So 1, 2, 0, 1, 2, 3, and let's put the H back in there. Yeah, so it puts it right back in there again. So really, really friendly, really powerful. There's also another function called remove. You can do that too. Okay, remove, that's the same thing as pop. The difference is that remove does not return the data back. If you do a pop, it will actually return the value that was removed, and then it also remove that from the list. So the pops will retrieve that data back, which is kind of helpful. Because if I say like, let's see, if I put like data, let's put d equals to message.pop 3. It does it for me, but D also returns the letter or the word that was removed from that list. Okay, so the pop gives that advantage, because you may not know what that word is. I know the index position. What is the content? If you're interested in the content, you use pop. If you don't really care, you just move it, you just got remove, then they will do the same thing too. Okay. So one thing to be careful with list is that, remember, the list is like an array. Okay, it has the index position always from 0 to n. Even if after I remove a certain element from the list, the index will always get re-indexed automatically. Okay, if I remove index 2 element out, it doesn't mean it's going to go to like 0, 1, and 3. It's not. Everything can be shuffled again, and then the index will start again from 0 to n again. And this is, be really careful, because let's just say that, I have, all of you guys are in my classroom, and I assign you to each element in the list. So let's just say index 0 always refer to, I don't know, Jack, right? And then 1 be Cody, right? And so on. And later on, if I remove the first position, if I move Jack out of it, so 0 is now gone, and then now you've been replaced with 0, and Jack is out. So if I try to say, okay, Jack is 0 position, I get that. No, I don't get Jack, I get Cody. Right? So that is not safe in terms of data integrity. And which is why when you do something like that, if you want to retain those data as you move things around, then we use something called dictionary. We'll do that later. A dictionary will always give you that safeguard thing. So it keeps track of your data as you move around. It has no effect on the actual data itself. Okay, so be really careful with that with lists. How are we doing time? Good. Okay. Okay, so list, again, list is like a array. That means what we did so far up to this point, this is what's called a single dimension list. List can be multi-dimension, right? You can have multiple dimensions in lists. So if you think about multiple dimensions, that means it's a list of lists, okay, and of lists and so on. So a 2D, 3D, ND dimensions can be created in list. And that is by doing something very similar to array as well. Let's do that here. It's really useful, very powerful, also very confusing at the same time. Yeah, so I'm going to comment all these out here. And I'm going to do this down here at the bottom. This is, what two here? 2D lists. Okay? These are all 2Ds. So, a one dimension is the one that we did so far. If I have like data is equal to 1, 2, 3. This is a 1D list, one dimensional. Okay, 1D. A two dimensional is a list of lists. So it will be something like just call it numbers. Let's call numbers for nice, easier to do that way. Of numbers. So inside here, so each slot, the first group is a list. The second is also a list. And the third is a list. So this is a two-dimensional list. Okay? This is 2D. Because inside this list, I have additional lists inside. And each of this element is a list. Okay? So what you get is a two-dimensional. And this is kind of hard to see the way it is here. But if you think about 2D, really this is just a table. Okay? This is exactly the same as a table. In an Excel sheet, a regular table you always see at the time, it's a two-dimensional table, rows and columns. And each element here in this way represents the rows, and each item inside that row represents the column. Okay? So if I put like 1, 2, 3, that is a 3-column. Has 3 columns, and this one has 3 rows because I have 1 group here, 2 here, 3 rows, and 3 columns. Okay, so if I put here then 4, 5, 6, and then 7, 8, 9. So this is a 3 by 3 table, really, what we call this matrix, right? 3 by 3 matrix. And if this is hard to see, you can do it multi-line, like that. So now it's easy to see. Yeah, right? And it's row 0, row 1, row 2, column 0, column 1, column 2. Yeah, but if you print it out, you're just going to have a list in a single line. It doesn't look that nice, but at least you get all the data printed out like that. You print it, and you get just a list of it like we created manually before. It doesn't have the nice formatting output, but at least that's a two-dimensional list. Now, this list here, this 2D matrix here, is a square, right? It's a 3 by 3. You can have, 3 by 4, 3 by 5. So we call these like square or rectangular list. But it doesn't have to be. Okay, it can be any size. Maybe the third one might have only 2 elements in there, right? So it could be a it's a what's called it's a jagged kind of list. It's not rectangular, and sometimes that's important because maybe if you think about this as a company, you have companies and each row represents a city or a state, for example, a state. So the state of Wisconsin, I have 3 company locations in the state of Wisconsin. I have 3 in Illinois, and I have 2 in Minnesota, right? So each element here represents an office, and each row represents a state. So you can see that it's possible to have a non-even size or irregular shape in here. Okay, so now we have something like this. When you loop through that and print it out, it can get really tricky. Okay. So let's deal with the even shape, the rectangular list first. Now, to print this out, you have to think about this row here. It will always be row and column. It's not column and row. Okay, it's always rows and column. And then, so I have to reference this element, which is the first list. This is the index of 0. You print the entire list there. This is index of 1. Second row, index of 3. Okay, and like that order. So if I save this, and I'm going to run it, so I guess so the data are stored inside the memory here, and then we just use this to do the manipulation here. So here is my list here called numbers. If you want to print the first set of numbers, I'll put numbers of 0, and that will give me the entire list inside the index of 0. Because this is the 0th index, it's a list. So I get a list of all that, and it returns the entire list. Okay? So it's like an outer list that contains a nested group of lists inside each other. So be really careful when you do this. And then if you want to know the size of this list called numbers, then you will just do the same thing, len of numbers. In this way, it's going to give you 3 because there are only 3 in that list. And so it's a little confusing. I'm going to add another one here, okay? I'm going to add maybe like a, I don't know, 10 here. The second group will be 20, and then the third one will be like 40, 30, and 20 and 30. Just to give you a different size, different length in here. I'm going to run it again to save that into memory. Okay, so I showed you that if I do the length of numbers, it gives me 3 because there are 3 in the list, only 3 rows. So if you have a 2-dimensional list, when you just say length of the numbers, it's going to give you the number of rows. How do you know the number of columns in there? Right? How do you know how many columns? I can see there are 4 columns. How do I get that? Okay. So this is the tricky part. If it's a square or rectangular list, you can pick any row. It doesn't matter which row. It's going to be the same column, right? So you would do something like, okay, I want the numbers at row 0, for example, and give me the length of that. Element 0. And it's give you 4, so I know the length, the column is 4. If it's a rectangular matrix, okay, rectangular list. If it's not rectangular, it's not true, because some rows has fewer, some have more. Okay, when you get to that point, then we'll do this after the break. When you loop through that 2D list, if you are not careful about the columns, you get into an error where you have an out-of-bound index, right? So it would say a range, for I and range from length of numbers or numbers of 0. Well, that only works if you have 4 columns. When you reach one that has 3 columns and you try to access the 4th value, it's not there, you have an error. Okay, so you have to be careful with that one. Okay, so that is a two-dimensional list. I'm just kind of curious. What do you think what a three-dimensional one look like?
List inside of the list inside of the list.
Right? See how crazy that can get? I mean, each element here has to be a list. So that means I have to do like that. Okay, a list in there. And then this is a list. Well, yeah. I think I messed up there. Yeah, it is a list. So a list in here. We don't close that yet. So this is another list here, and then list here. So now this is a three-dimensional list if you keep doing this way. Okay, if I do this way, it's possible to do that too. I have the first row is a three-dimensional, the second row is two-dimensional, right? So you can see how this can get like a really weird shape now. Because when we do about three-dimensional, we're talking about the z index now. We have the x, the y, and then the z, the depth. What about four dimension, right? You can see how crazy that gets. It's hard to visualize it. Yeah, it's hard to visualize it because a four dimension is really the intersection of two 3D objects. Okay, if they're connected, then that's a four-dimensional object. And it's hard to visualize. So a fifth dimension would be you see how that gets, right? It was really complicated. I mean, it's hard to visualize it, but to represent data, it's not that hard. Because I can go index this, index that, index that, index that. Okay, so really pretty straightforward. But let's not go there. We're not going to do 3D here, okay? So no 3D stuff, just 2Ds. And if you want to challenge yourself to go 3D, cool. Build games, right? All right, so those are the two. We're just going to stop at 2D. I'm going to go to 3D here. Okay, that's enough already. But with this 2D list, you can build, you use that for many real world, solve many real world problems, like the one on the homework assignment. Okay, I'm sure you read that already, right? About the theater seatings in the theater. How do you do that? Again, list is mutable, so I can pick a seat and change the data. Right? You cannot do with a string, but list you can. So that's pretty cool. All right, so I showed you the two-dimensional and one-dimensional already. So now let's talk about how do you iterate or loop or print the content in the list. Because we know that we can access them using the index. So it's very similar to how you would do inside with a string. And this is why Python is pretty cool for that. It's really easy to do for that. I'm going to clear my variable here, just in case I might have duplicate data. I'm going to get unexpected results. So clear my cache. So now I'm going to print this list here. The first one, the data, is pretty easy, right? And again, you're not limited to number. I put numbers here, but it could be anything. It could be strings and objects and booleans and all sorts of content, because Python doesn't really care. So to print the data from the list, if you don't know, because the list can be any size, and so you do the same thing. You can use a while loop if you want to, but the easiest one is the for loop, right? For, now remember that every, the I here, if you call it I, the I is still referencing the element, the index of the list. It's not the actual content, it's a list. If you're using the range, okay, if you're using range, you're just going to get the index of that list, the same as string. So if I say the index in the range of the first, just one dimension, the data, you say length of data, right? That's going to print everything from the list. If you print it out, you would say print the data of I, just like string before, right? No problem there. Bless you. So I'm going to comment the one here. So that will print every element inside the data list, starting from 0 to 2, because it does include the length, which is 3. You print it, you get 1, 2, and 3. You're right over there?
Yeah.
We're not even 2D yet, come on. Yeah, so it prints us out, right, just like string before. Because I'm referencing the index, I access the index, and I have to use that to get the data out. So this way you have control of the positions in the list you want to print out. If you don't care about the index, if you just want to get the actual content of that, then you use the for I and the actual data. And if you print I, you get the data out. We call it I because we like I. But if you do it this way, then usually this variable here will be more meaningful, like each number. Okay? For each number, insert the data, print the number out. If it's a list of numbers. So when you see it, okay, I get it, it's a numbers. Or for each integer, or for each name, right? Which is why when you put numbers here, say for each number in numbers. Okay? For each word in words. For each user in users list. If I print it out, I should get the same result. This is the first one. This is the second one. Okay? Yeah, so you get the actual content or the index. And you may wonder, so which is better? Well, they're about the same. It's just that this one here, I can control the index. This one, I don't know the index. If you're interested in the index, you use the range. If you're not, just look to the data right away. Same thing with strings. Okay. And then maybe maybe I must check. Okay, if the index of I, if it has a number 2, then I might want to replace it with number 4, or I might double the number. Right? You can do that by using the index. Here, if I say, okay, if number is 2, then double it, but you cannot assign it back to data because you don't know what the position is. If you want to do that, well, you have to create a counter outside of it. And increment a counter, right? So you have another extra variable. If that's the case, do it this way. Okay. Any questions? So we'll take a break. We'll come back. We'll do the 2D. We'll print that out, and we'll do some manipulation with 2D. So I'll see you guys back in a couple minutes.